One. Good afternoon or morning or whatever it is, wherever you are.
We should just start with good day to you. Good
Maybe.
day to you.
Yeah. Are we gonna woo pig or what?
I mean, I'm just not gonna do it. I
We're not,
mean, like, I got you, but
we're not I should have asked you that before I started recording instead of putting you on the spot. Apparently, Miss Young doesn't like the Razorbacks, but woo
I
pig.
feel like you're overstating. You're overstating. What I don't like is like woo pig sueying,
Oh,
which sounds weird when I say it.
yeah. Well, okay. So let's go ahead. Oh, I guess I should actually read the title. We're going to talk about rational and radical equations in this section, and those sound really fancy. But rational means fraction, and
Fraction.
and radical means like square roots or cube roots or roots. Or as
I'm gonna call it nth root.
my grandma would call it a root. By the
A
way,
root.
a root. Yep. Okay.
Oh, you're doing it.
All right, now we're doing it. So we're doing rational equations. Everybody loves fractions. I mean, Miss Watson, Miss Young and I love, Miss Watson likes fractions too. Miss Young and I really love fractions, and we just like, play around with them for fun during the weekends and stuff.
Without fractions, your friend can't have their Snickers bar with you.
Okay. But for those of us who don't particularly love fractions, there's a way to make our lives easier. If we find the common denominator and multiply both sides by it, fractions will go bye-bye. And so this is an easy one with common denominator of 15. So if I multiply both sides of this equation by 15, something magical happens. When I multiply the 15 times the first fraction, 15 over 5 leaves me 3. So I would have 3. Oh, you're doing it. Okay. So 3x plus 2. And then when I multiply 15 times this fraction, the 15 over the 3 becomes 5 times the quantity x plus 3. And you can keep on going, and I'm going to put the right side on here.
He said, I'm sick of waiting.
I want to do something. Okay. So that equals 15. And the beauty of this is that now I ain't got no fractions no more. Okay. I ain't no math or no English teacher either, right? So you don't just shush. Okay. So now we just solve like any old other rational or any old regular linear equation. I get 3x plus 6. Let's see here, what 5x minus 15. And that equals 215. Oh, so what am I going to end up with now? 8x. Is that 9? Last time I checked. -9.
Yep. -9.
And equal 15. And can I just go right to it? It'd be 8x equal to 24 when I add 9 to both sides, 24. So I get x equals 3.
Yeah. And guys, as you're working through these problems, you always want to make sure you're asking yourselves kind of right at the beginning, is there any kind of issue with this equation? So in a previous video, we talked about if there's a fraction, we can't have division by 0. And if there's a radical, we can't take the square root of a negative number. So as you're working through these problems, you always want to think about your answer and think if it's appropriate for this problem. Check, 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 check your work this time.
And so you're right. Like, I don't think a video has gone by where we haven't talked about division by 0. I mean, maybe we're a test or something.
We think we are.
We might have a problem, but and I want to point out though, if I take that x equals 3 and put it into the original expression, that second fraction is going to have a 0 in it, but it's going to have the 0 in the numerator. If we get a 0 in the numerator, it's not the end of the world, because that's 0 divided by 3. And if I've got no cookies and 3 friends, we each don't get, a cookie. So we're cool with that. Okay. So
I just wrote what he said. What he's telling you right now is like if we were to plug a 3 in, we get 5 over 5 in the first one. We'd get 3 minus 3 or 0 over 3 in the second one. which is perfectly fine. It's just 0. So 5 over 5 is 1, and 1 minus 0 is 0, so that checks your work.
So we're really not talking about division by 0, so maybe we aren't obsessed. But don't worry, it will be. Oh my gosh, we really.
I didn't put any earrings on for you guys today. I have naked ears. I mean, I have this earring
Neither
in.
did I. I didn't put any earrings. I have more holes in my ear than you do. So.
I mean, I have 7.
Well, I used to have 9. So yeah, I win.
Yep, you win.
All right. All right. So now we got to worry about. I told you the division by 0 would be back, and the x minus or the denominators can also have variables in them. So my common denominator, thankfully, is common, w minus 7. So I'm going to put w minus 7 and then multiply both sides of the equation by that expression. And that's going to, the w minus 7 is really like over 1, and those will divide away. This will divide away with that. Okay, and so will this and this. I'll be left with 49 equals to w squared. To use my best Bush. W
squared.
And when I square root that, or root it, as my grandma would say, I get a plus or minus. I was getting there. Gummit. I end up with plus or minus 7. Plus or minus 7 equals to w. Now there's a problem here, because that really actually means I have 2 solutions, right? W could equal to 7 or negative 7. We sometimes get lazy and write the plus or minus. It equal to 7 or negative 7. One of those is going to cause me to have my division by 0, and it's this guy right here. He's no bueno. That one, when I put the 7 right in there, I would get 7 minus 7 or 0. So I'd end up with a division by 0, which is no good. Okay? So our only answer is w equals to negative 7. You must check your work. Okay? So I even put it in the title. And we don't mean to like check and make sure that I know the square root is 49. Check your answers, I should say. Really, it should be check your answers.
Yeah.
That's probably the better thing to say.
And he didn't mention this, but this is called an extraneous solution. So all of his work is completely legitimate. He didn't do anything wrong, but one of his answers doesn't work because of a restriction in the domain. That means it's an extraneous. Did you put it in the next slide? Extraneous solution.
No, I did not ever put that, mentioned it in the thing. So, and I don't even know how to spell that. Thank you.
Weird. It's weird spelled.
Yeah, it's a false solution. Okay, I did nothing wrong. She's right. I usually make mistakes. Well, no, I never make mistakes.
No, you've only made one that I've ever seen.
Yeah, it was my first mistake ever too.
Right.
But when you make, I didn't make a mistake. The process yields a false solution, and that will happen on these rational expressions or rational equations. All right, so think about this problem for a minute. This is a much more complicated LCD. So take a moment and think about how I could find out. Is there a way I could condense this? What do you think, Ms. Young?
I think that unlike a number, I struggle seeing the factors of a polynomial. And so I might want to factor it. So what I'm saying to him right now is like, if I wanted the least common denominator between, let's say, 1/12 and 1/16, right? It would help me to find the common denominator if I knew that 12 was 4 times 3, and I knew that 16 was 4 times 4. Because now I can very quickly see that this one's missing a times 3, and this one's missing a times 4. And so what you have to do here, and I know you've seen something similar to that before, what you have to do here in a problem like this is you have to find the factors before you start looking for that common denominator, because if you just start multiplying by all those denominators, you're going to end up with something not solvable.
That's
Okay.
just monstrosity. So
Right.
I'm going to factor each of those expressions in the denominator, if I can get my act together here.
The difference of squares factors to conjugate pairs.
It's my stylus, not the math.
Sure. So
Here.
you can see 4x plus 12 factored to 4 times x plus 3. Then you've got an x plus 3x minus 3 in the next denominator, and an x minus 3 in the next denominator. And so once you have it all factored out like this, you can just sort of see what factor is missing, multiply the top and bottom of those fractions by what's missing. Ooh, you're going to not do it the way I would have done it. Okay, you do it the way you're going to do it.
Okay. Oh, you were going to do each fraction separately?
Yeah, just to keep it from like, because sometimes I think it's a little confusing to see just, I'm going to use one of these and one of these and one of these.
So, all right. So you're going to, what's missing in the first one is an x minus 3.
Yep.
Okay. And an x minus 3. All right. What's missing in the second fraction?
4.
So I need a 4 here.
And as we're deciding this, guys, we're deciding this based on what's in the denominator only. We want to make those denominators exactly the same.
So I need a 4 and an x plus 3.
Yep.
And this last one, if that's the way you wanted to do it. Okay. And I like it. It works. It makes me feel pretty.
And I think now you can very easily see the common denominator of 4 times x minus 3 times x plus 3.
And all of those fractions, when I do that, are going to have the exact same thing in the denominators. So what does that buy me then, Ms. Young?
Well, I could, at this point, multiply both sides of the fraction times 4 times x minus 3 times x plus 3. But what's going to happen is, because those are already all exactly the same, the denominators are going to wipe out. And I'm just going to be left with the numerators. Ain't she pretty?
What are we getting on the other side? 20 x minus 3?
Plus 3?
Plus 3. That's what I said. Told you it was my first mistake ever.
So we just wiped out the denominators, guys, and we went with the numerators. That was not super sleek, but I think you get the point. Make sure you carry that minus between the fractions with that 4.
What is that? 60? Yeah, 60.
Plus 60.
I can do math. I promise you I can do math. Let's see here. So I'm going to get, oh, you're going to love this problem. 67 equals 19. This can't be right. Because Ms. Young told me to check my answers, and I don't really want to put negative 67 19ths into that problem to see that it works. What do
Why
I
add a calculator? Why can't I?
What do I really care about in this problem? That's the right answer. I think that's the right answer. I'm pretty sure that's the right answer. But I don't need actually find out. I mean, I can plug it in and do the math and see that it works. And Ms. Young's right. I could use my calculator to check the math. But what am I looking for? I'm looking for, does that number that I came up with cause me to have a division by 0?
So I'm looking at the denominators from the original problem, and I'm thinking about, what would I plug in to cause 0? For example, 3 minus 3 is 0. So that tells me that x can't be 3, which is fine because x wasn't 3.
Yeah, I don't know what 67 19ths is off the top of my head without a calculator. It's like 3 something. But it ain't 3. It's 3 something, or negative 3 something.
Same thing here, right? 3 squared minus 9 is 0 again, or
negative 3.
Negative 3 squared minus 9. So I know that x can't be negative 3 But again, my answer is not -3, so we're cool there.
Yep.
And then same thing here. 4 times -3 is -12, and -12 plus 12 is 0. I already said it couldn't be -3, but I already cleared -3 as well. So this guy is a perfectly fine, ugly answer.
Kind of like my dog, right?
Um,
I don't know if you saw my dog is so ugly. You also could have told that from the second line where I had it factored. It would be very easy to see that 3 and -3 were my offensive numbers. Okay?
Could have stopped me 10 minutes ago. It's fine.
Okay, save for a little time, but you know, you're so all right, moving on. With radical equations, we're basically going to do like we've done with every other equation. We want to undo the process, and the way you undo a radical is by multiplying or raising each side to a power. And it's often, I mean, it's almost like not even thought of. Oh, thank you. I was about to put that 2 there. That when there's no index there in the root, there's an implied 2. So you probably knew that. You don't even have to really think about it. But to get rid of it, if I take a square root and square it by radical, so what thou doeth unto one side of the equation, thou must doeth unto the other. So I get 4x minus 3 equals to 25. And I go to work. So 4x is equal to 28. And then I get x is equal to 7. Am I okay? So again, we should check our work. If I put 7 back in for the original equation, I'll get 4 times 7, which is 28.
That was ugly.
And 28 minus 3 is 5, and the square root of 25 is 5, so I'm good.
Here's another thought here, and I maybe shouldn't sidetrack to this, but I'm going to do it anyways. We talked about how to find the domain of a function, again, in a previous video. And when we had a square root like this, we said, okay, the rule is that you can take everything underneath the radical and say, okay, we know it has to be 0 or bigger than 0, greater than or equal to 0. So we could just solve this, add the 3. We get 4x is greater than or equal to 3. Divide by 4 and say, okay, as long as our x value is greater than or equal to 3/4, then we're good to go. Is 7 greater than or equal to 3/4?
Yes,
Yep, we're good.
Yeah, we want you to check your answer, because in this section you can get what's called an extraneous solution, and I'm not going to try this. Well, maybe I can spell it. Let's see if I can spell it. EXTRANEOUS. Is that right? That's the spelling of extraneous solution. And we keep using that term. Extraneous is just a fancy math word for false.
Yeah.
Right? It's like, you know, when a guy tells you he's going to call you.
Wow. Why can't it be the girl? I guess that makes the guy the bad guy. No, okay, I'm good with it.
Whatever, I don't know.
You can stay with your example there.
Okay. The only problem with the radical problems are where you have to get the radical alone by itself first as best you can. So if I square this as it sits, it's going to be a hot, ugly mess, because when I have the binomial, it's just going to be straight up ugly. So if you have a square root and you can get it by its lonesome, do it. Okay. So I'll get the square root of x minus 4 equal to 4.
So what he's saying, if there's anything added or subtracted outside the square root, if there's anything multiplied times the square root, if there's anything divided underneath, go ahead and get rid of whatever is there by just undoing the operation, and then solve from there.
And using your logic from a few minutes ago, what would be an offensive number, or my offensive domain number for this?
So we know we want x minus 4 to be greater than or equal to 0, because that's the piece that's underneath the radical. So if we add that 4 over, we get x is greater than or equal to 4. So as long as my solution's greater than or equal to 4, I should be good to go.
I am good to go because I got 20. So I'm good to go. Okay. All right. So this isolating, if there's and like you said, if there's a number multiplied times the radical, you have to divide by the number. Whatever you got to get the radical alone. But there's a problem with what we just said, because I can't leave well enough alone. What if I have 2 radicals? Oh no. Well, you're gonna separate these guys
I
and
think you
then
get the square root of 5p plus 10.
I'm sorry, what?
I think you get the square root of 5p plus 10.
Oh no.
No?
No, you can't add square roots.
You can't do that?
No, not they're not like radicals. They have to be the exact same radical. Now, if they were both 4p plus 5, then I could add them, or both 5p. But like if I have the square root of 2, oh, sorry. Oh, there's my donkey. If I've got the square root of 2 plus the square root of 2, that don't make no square root of 4. That equals 2 square roots of 2. We talk, yeah, that's like middle school radical arithmetic. You can't add the radical. You have to be like radicals.
Were you trying to shame me just then?
Yeah, a little bit. You're the one who won't woo pig, so I'm just gonna just leave it at there.
Whatever.
Okay.
Can we at least move one of those radicals over with a number? Or are we going to square the radicals?
I don't want to deal with like a binomial with two radicals, so I am going to separate the radicals because I at least don't want to have to I don't want to have to square that thing and have to do the radical times the radical and the radical. I mean, it'd just be a hot ugliness. Okay, so I'm going to bring this guy over, and so I'm going to have 4p plus 5 under a radical equal to 3 minus the square root of p plus 5.
Yeah.
Okay.
Okay, I'll accept it.
And then I'm going to square both sides because that will clean up the left side. All right.
Goodbye, square root.
Goodbye, one of my square roots. Okay. But on the other side, I'm going to, now, for the love of all that is good and holy, we've talked about this before. Do not square each of these terms. That's 3 minus the square root of 5, p plus 5. I have to lay that thing down twice, right? So I'm going to get 9 minus 6 square root of p plus 5. And then plus p plus 5. And
I know our students are brilliant, but I'm just going to write it as a side note just in case they're like, what in the world is that?
You have to put that expression down twice and then do the distribution, and you're going to get 3, you'll get negative 3 times the square root of p plus 5 twice, and that makes negative 6. Okay?
Make sure when you guys do this that this becomes a plus because it is a negative radical times a negative radical.
I think I meant to do that, but there's no proof now. So now I want to, now I can, this is like the shampoo bottle that says wash, rinse, repeat. We're going to repeat. Now we got to isolate again, okay? And if I was mean enough to give you 3 radicals, we might have to do this a couple times. I never will. I promise you I'll never give you more than 2 radicals. So now the one that I want to isolate is this guy right here. If I can get him by himself, then I can square it again and go on about my busy day. So I have 4p plus 5.
So he's cleaning up the right side right now by combining like terms. He's not going to do 9 minus 6 though, because that 6 is attached to that radical. He's going to do 9 plus 5.
Which is what, 14?
Mm-hmm.
And
so notice that minus 6 square roots of p plus 5 is just going to hang out down there at the end.
So I'm going to bring these 2 terms, the p and the 14 over. So I'll have 3p minus 9. Yes. Yes.
I like it.
Equals negative 6. And then square root of p plus 5. Now, we didn't have this in the earlier problem, but I got to divide both sides by negative 6. So this is going to be fun.
This problem's too long. I don't like it.
Good. It puts hair in your chest. Negative 1/2 p minus 3/2 equals the square root of p plus 6. Yeah, maybe I could have picked a better example.
Can we make this a plus 3 over 2?
Nope, we cannot, but we might as well because it's right. And I can square again. Okay, and again, when we do this, we're going to have to do what Miss Young did up here, but this time with this expression. Don't shake your head at me.
This is so ugly.
This is like my ugly. I'm going to get Holly to come here and show you the ugly dog.
Hold on, let me erase my side note up here so that you can like
move it on up.
Yep.
Be like the Jeffersons and move it on up.
Move it on.
So nobody will know that reference. So I have 1/4 p squared, right? Oh my gosh, this is ugly.
That's what I'm telling you.
What was I thinking here? Who picked this problem? Oh yeah.
You picked this ugly problem.
1/4 p squared. Let's see, that would be -3/4 and -3/4. That'd be -1.5. So that'd be what, 3/2?
Yep.
Check my math. And then plus, who said they liked fractions? Oh wait, that was me. 9/4.
I only like it when I'm getting half of somebody's Snickers bar.
And then on the other side, what I really want is to get rid of my radical. And at least I've done that. Now, I know this seems worse than it ever could have possibly been, but I do.
Yeah, but what we got here, Mr. Bobby, we got a quadratic.
We got a quadratic that we have to solve. Yay! And I could multiply everything by 4 to get rid of fractions using our little trick before. P squared minus 6p plus 9 equals 4p plus 20. So p squared minus 10p minus 11.
Yeah.
Look how nice that problem turned out to be. Yeah, it'll factor. See, I knew what I was doing all along. That's why. Except there's no squared there.
There's not.
If you need help with the factoring, there is a factoring video. Wait, this is the, never mind.
This is after the factoring
That
video.
is after the fact.
But if you're struggling, it's all right.
The factoring.
-11 that I had to get -10.
So I get all that work to get x equals 11.
Can we get p equals 11?
Oh, that's what I said. P equals 11 or -1. All right, so all that, you're probably thinking, oh my gosh, I'm never going to be able to do this.
So real quick in the domain, p plus 5, p's got to be greater than or equal to -5. Are we okay? Are both of them greater than or equal to -5?
Yep, but what about the other square root?
Okay. So we subtract 5, we divide by 4. P's got to be greater than or equal to -5/4. How are we doing on that one?
Is -1 greater than -1.25? Yes, it is. So
it's on the correct side of it. On the, think about your number line, guys, if you're a little like, what?
So that one worked. Now, I mean, I admit that's a really rough problem, but mainly because I had ugly fractions. If I'd have, but again, we can clear the fractions using the technique we did earlier. So, I mean, obviously, I'm going to give you like 7 or 8 of these on the quiz. So, hi, why am I talking to your, who's on the phone? Oh my gosh. Come on, woo pig for me. Woo!
We just got excited that we finished the problem. That was like this. This is our first like full screen problem.
I know, really. I mean, come on, like it's college. This is real hard stuff, all right? Don't wimp out. You can do this. I don't want to erase this. Can I just like show them the homework?
With it on there?
With it on there, and then
Nope.
the blue, and the dog and blue and the shoes.
There's too much happening.
There's too much happening. All right, well, here, I'll move it over so you can see the ham and eggs, or green eggs and ham. Oh, no, those are just bacon and eggs and sparkly shoes.
I love breakfast.
Yeah, I might have breakfast for dinner.
Not off your feet, but like I do love breakfast.
Yeah, but boy, I wouldn't mind having breakfast for dinner. So, all right, bye, y'all.
Bye.
Hold on.